All right, what about this next problem? Problem 8. It is asking you to sum up, because that's what the big E means, right? Summation. Sum up a list of numbers that's created by this equation. And this first number is when you plug a 1 into I, which is way up there in the exponent, and keep doing this forever. I want you to plug in 1, then 2, then 3, then 4, and don't stop, and then add up all those numbers. And you're like, well, that's ridiculous, but not really. Remember, the rule is about an infinite sum is this formula is really easy. It's a1 over 1 minus r, but that's assuming that r is less than 1. So we got to find out, what are they multiplying by? What is that r value? What is that common ratio that they keep continuing to multiply by? And so 2 ways to figure that out. 1 is to brute force it, kind of start building the list and see if you can figure it out. Or 2, looking at the equation. Sometimes it'll give you a hint, but I won't. I'm going to plug a 1 in. That'd be 1 minus 1 is 0. Anything to 0 is 1. So the first number in the list is 6/5. The next number in the list is when I plug a 2 in. So that'd be 2 minus 1 is 1. 1/5 to the 1 is 1/5. Times 6/5 is 6/25. And then I might plug in, try to find the third number in the list. So I plug in a 3, I get square. That's 1/5 squared, which is 1 over 25, times 6 would be 6 over 125, and so on. So you might see what they're multiplying by. And another way to find that, if you had to, is if you knew it was geometric, which we are told it is, then we could take like the second term over the first term or the third term over the second term. We could do whatever we want and figure out what it is. Lo and behold, you will notice it is 1/5, which is the number getting the exponent, right? If they're going to keep multiplying by something, then we're going to use exponents to indicate that. And therefore, that's how I know what r is. So r is 1/5. Now, is 1/5 less than 1? Heck yeah. So this is actually summable. These numbers will start to get so small that they are like just adding zeros to the total, and it won't matter any. So let us see what our total would be. All right, so the sum is the first term, which was 6/5. Good thing I already did that, over 1 minus 1/5. So that would be 6/5 over, that'd be 5/5 minus 1, so 4/5, which is 6/5. Copy, change it to dot, and flip the denominator. And you see you get 6/4, or 3/2, or if you want 1.5, and that is your sum of an infinite number of terms for that formula. It's going to add up to 1.5. Have a great day. Stay happy.